Hello, I'm Eric Snodgrass, and thank you for watching this in-depth ag forecast for Australia. If you don't mind, I'm going to start you half a world away over in the Caribbean. We had an incredibly powerful hurricane with 185-mile-an-hour winds rip through parts of the Caribbean. And you're looking right now down, and underneath here, you can see the land of parts of Jamaica. So this is kind of the stadium effect of these massive eye walls that we get with some of these powerful hurricanes. Now, what drives hurricane strength is always ocean temperatures. So whatever the ocean temperature is, you can derive the maximum strength the system could be, as long as all the other environmental characteristics are going to be, for lack of a better way of putting it, kind of behaving to allow the system to develop. And they did with this. Low wind shear, no major steering currents. It just sat over hot water and it exploded. And if you look, this is kind of a view of where what's left of Melissa is moving. So Jamaica is here. The devastation is just unreal. We're kind of getting reports this morning of how bad it was yesterday. In the overnight hours, it moved over parts of Cuba and is now going to move over the Bahamas and make its way out to the open ocean. But I wanted to show you a couple of things about this hurricane, because we took our hurricane hunter through it 5 times the other day. And if you've never seen what it looks like to fly through a hurricane, you're about to see it. So this is all cloud, but then as we get in, there it is. That's kind of the opening up of the hurricane eye wall. And again, you're staring at one of the most powerful hurricanes in world history that just went through this part of the Caribbean, through Jamaica and across Cuba. So just for a little bit of understanding, the cloud in front of you is the eye wall. You're in the eye, which is clear, very hot in the eye. Sometimes the temperatures they approach nearly 38 to 40 C. In fact, that's what drives the hurricane. It's how hot it is in the middle, keeping the pressure low. But the cloud bank you're about to fly into was moving in front of this airplane at about 175 miles an hour. And that is just how powerful it was. And we fly into these all the time. I've actually been on the Hurricane Hunter multiple times. I've never flown in a hurricane, but I've used it for other research projects. The one that I've been on is the C-130 that we have. Here's another view when they went into it again, and now you can see the sunset on the other side. Just incredible. I've never seen video quite like this. I've watched them fly through hurricanes many times, but I've never seen video quite like this. Now, I want to show you a couple of things here. First of all, we have our traditional ways of tracking these and predicting where they're going to go. And this comes from the United States National Hurricane Center. But you have a hurricane season as well. And I want you to know of a tool that I want you to kind of bookmark if you feel like it. It's this one called deepmind.google.com/science/weather lab. And what's nice about it is this is global, but it is tracking using the European model, using their own machine learning models, where this particular hurricane is going to go. And what I'm excited about is, like I mentioned, this is a global feature. So later on, when we have these tropical events that are north of us, you'll be able to come through here and track where they're going to go as well. deepmind.google.com/science/weather lab. That's a great, great resource. Now, you saw a moment ago that this particular, the remnants of this hurricane are going to be moving toward the North Atlantic, maybe even toward Europe. And so kind of, since we're starting on this side of the world, I just figured I would tell you what I expect to have happen there. One last thing to point out, remember that we are in the Northern Hemisphere, so all of our low pressure systems, they spin counterclockwise, like your high pressure systems do in the Southern Hemisphere. And that's just a factor of the fact that the Earth is round and spinning. It's called the Coriolis effect. So take a look at Europe. You're going to see several deep lows ripping across parts of Europe. Now, we're in fall, right? We're about to start November, which is typically a month where we start to get cold and snowy across the north. But there's going to be multiple huge storm systems coming through the area. And I'm thinking about it simply because, we have a winter wheat crop that's becoming established in Ukraine and Russia. And if we look at it the next, let's just say the next 10 days, we're drier in Ukraine, drier in parts of Russia. I don't think this is a red flag or anything to be overly concerned about, but just wanted to point that out as we're thinking about this international weather stuff. Now, over the last 10 days, that same area had been wet. So to see it go over dry is not a major concern. But if we look back over the last 30 days, let's just kind of get an idea on this last month, we've been drier in northern parts of Russia's wheat belt here, but overall the moisture's been pretty good. We've had a lot of flooding in India. There's been flooding north and along the Yangtze River, drier in this part of southeast China. And I just wanted to point out these other kind of international areas to you before we dig hard into what's going on in Australia. So speaking of Australia, here is what the month of October has delivered. And we've been paying close attention to some dry patches that we've seen down here in Western Australia. And then, of course, the very dry conditions in pockets of Victoria and New South Wales, chunks of, I don't know if that's a meteorological term or not, but parts of Queensland, but definitely here along the coast. Now, I got to thinking about this, and we were trying to predict this back at the beginning of the month. And I went back to September 30th, and I had saved the October forecast. And I got to be honest with you, that's not very bad. Like, that's pretty good. I mean, it picked up on this risk here of being drier. And sure enough, like, look what we had here. And I like to do this every once in a while because we're trying to instill some confidence in a weather forecast model. And what I'm about to walk into here is where I think this is all going to go and what it might possibly mean. And we need to know if we can trust the European model as we look out there farther. Now, I got an email from one of you about the winds so far this spring. And I thought it was interesting because I don't remember when forecasting very strong winds across a lot of Australia's growing areas. But I went back and I made a map looking at the composite average wind speeds from September 1 to a couple of days ago when the data are most fresh. And I'm like, well, wait a minute, look at Tasmania, just extremely windy. In fact, when you compare it to average, which is what this map is, so this is an anomaly map, I mean, we've had wind speeds here that have been between 4 and 5 meters per second over that whole almost 2-month time period, faster than average. And that is significant. And the question was, are we having a windy spring? And I said, well, wait a minute. Well, if we're talking about Tasmania, yes. And then I went back and looked at the email, and the guy was in, so I'm going to try my new tool again here. I don't even know how to say it. But this, I misspelled it. H-U-O-N? Yeah, Huonvill in Tasmania. And so I'm going to go there, and let's have a look at this. So here we are. And in this new tool that I'm going to release, it's not public yet, but it's coming, which it'll be on AgWeather, I will have the wind history. And heck yeah, look at this. I mean, as we moved into September and October, these daily wind speeds were ferocious. I mean, we were looking at gusty days of 75 kph. Some of them were up here, over 80. And so we're trying to keep track of this and just monitor these things for you. And what's nice about this site is you can come in here and anywhere you want on the map, just drop a pin. I just clicked on the map and, it'll all update. So we're working on, so here I chose, I don't know how to say, your town names are amazing, by the way. But, I guess I'm in Lars Lee, I'm not sure. But, you'd be able to monitor these things plus your year-to-date precipitation, temperatures, everything. We've got it all there, including the 15-day forecast on precipitation from multiple models. Now, we were talking about winds a moment ago, so I want to come back and just point something out. Most of the very strong wind that we've been observing this spring in Tasmania has been largely due to the fact that for most of September and now almost all of October, except for the end of the first week of October, the Antarctic Oscillation, also known as the Southern Annular Mode, has been negative. And we know what that does to the jet stream level winds, right? We were increasing them in that area, and that translated down toward the surface as well. All right, we've been talking about winds. This is where we are right now. As I'm recording this, you're all just about ready to wake up. And I'm mostly concerned about what's going on here. I may not look like much, but there's a trough of low pressure, and it's going to be moving through. So let me show you what the wind forecast looks like. What I'm going to do is overlay on here in miles per hour, just to be clear, the wind speeds that we're expecting to see forecast through the next 5 days. And as we take note, very strong winds coming through here. And as we go farther into the forecast, you'll note that there's parts of South Australia about a week from now and beyond getting over toward, Victoria, New South Wales, where the wind speeds could be pretty gusty as this next deep low kind of takes shape and comes through. So, it's a great question about what's going on in Tasmania. Certainly, as we pulled the data out there, you can make the assumption that this spring has been one of the windiest on record. I don't have the full record length in that, but I wanted to let you know that we did observe it, okay? All right, next thing to talk about is your precipitation pattern. And overall, as I look at the next 10 days, we see above average precipitation, these colors, in a lot of areas. Now, we take note that there are some drier spots in this, and we have to continue to monitor that and try to figure out what's going on there. But overall, we're looking at a wetter pattern. And the atmosphere is sending the potential for some severe storms. Now, one of the variables, and this is going to go on AgWeather very soon for you, one of the variables that we're going to monitor closely is called CAPE. Now, what CAPE stands for is convective, in other words, thunderstorms, available potential energy, CAPE, convective available potential energy. In other words, how much energy is stored in the atmosphere to unleash as big storms. And what I want you to watch as I go through this forecast through Wednesday into Thursday and Friday is see the very high Cape values start to move their way into the coastal regions of, Queensland here. And so with the rainfall that's coming, we will have a destabilized atmosphere capable of producing some big storms. Now, some of the baddest ones are right in through here where the Cape values are very high in the forecast. But I just wanted you to take note that getting ourselves into this weekend, we will see the atmosphere destabilize, which gives us the chance for some of the rain that's going to come through here to be more in the form of large thunderstorms. All right, so that's kind of the bigger picture. Now, what's driving all of this is a very active weather pattern. So take a look. The blues are troughs in the atmosphere. These are regions of unsettled low pressure. The reds are ridges. And as we walk through Thursday, getting into Friday, watch what happens on Saturday, Sunday, Monday. A deep low is trying to cut itself off from the main flow over parts of South Australia, getting into to New South Wales, Victoria. Again, this is just out there early next week as it comes through. It's going to start this weekend. It'll be there through Tuesday, Thursday, and there's another deep low coming into Western Australia at that time. To see the atmosphere attempt to do this, though, is what's just critical to watch for the moisture to come through. So if we flip that over now and look at the precipitation type and intensity, we're now going to be able to watch a lot of these coastal thunderstorms, but you're going to see that big front swiping through. Ready? So this is through Thursday into Friday. So late this week, early in the morning, some more showers and storms here, showers and storms along the coast. But here comes the large low, bringing its front first on Saturday morning through parts of Western Australia. And then as we get into Sunday, there it is. There's that same front going toward Monday and Tuesday. The models are attempting to take a region of heavier rain, spin up a low pressure cell there. See the low pressure developing? And start to really increase the rainfall chances. And this is only 6 days away, 5 or 6 days away for us. This is next Tuesday. And that system goes through and swipes in, drops in a bunch of colder air behind it. And the next low, see it there, coming into Western Australia is only a week out. This is next Wednesday. So we are seeing a very active pattern set up, but it's a bit selective on where all of that precipitation is going to be. So you saw the anomaly map a moment ago. Let's play out the actual amounts being predicted by the European model. So I'm just playing out here through Saturday into Sunday. Now here we go, Sunday into Monday. Just take note, we've got the chance in Victoria and parts of New South Wales of grabbing anywhere from 20 to maybe upwards of 80 millimeters of rainfall. Again, this is always dependent on elevation and the additional lift we get from the atmosphere there. But the chances for some better storms along the coast. And then or midweek next week, we have the low coming into Western Australia. Now, you think about where that leads us into week 2, and you notice the models overall going out there day 8 through 14. That's November 6th through the 12th. I mean, it's not dry. It's certainly not dry. We have to ask ourselves what's driving all of this. So now I get into the fun part of this forecast. Temperatures, okay? Watch what the temperature does behind this. All right, let's take it back to the beginning. That's your next 5 days. Now watch the front come through, knocking the temperatures down across the south. See that? That's out to November 5th, 6th, 7th, 8th. We're going to be dropping in some pretty chilly air in here. How much? It's going to be 5 to 10 degrees C below normal as that system rolls through. We get out there, this is day 5 through 10, and then getting out there farther into the forecast, day 10 through 15. The atmosphere overall is setting up some pretty strong contrast with cold south and warmer to the north. And what's also taking shape during this time period is the MJO is trying to move over to this spot. So you can see the instability and the storms we're expecting north. But it is interesting to see that the new 1 month outlook, going all the way out there to through the month of November, is still drier in this corridor. And it did really well forecasting October. We've got to see if it's going to do well here. Now, I have a feeling that this is not going to be as dry as maybe you may think it's going to be. And I'd like to present that case to you, okay? So that is the new outlook for the month of November as we see it from the European model. So here's a couple of things I'm thinking about. The Indian Ocean dipole has driven itself way negative, more negative than it's been in the last 5 years. And I started thinking about what this means. Well, we know from BOM's great website on this, I do love what they did here, is that a negative Indian Ocean dipole is when the trade winds are doing these westerly wind bursts here, pushing the warm water over toward Indonesia, and cool water begins to upwell over this part of Africa. In other words, there's a circulation in the ocean that's doing that. Upwelling here, downwelling there. And it tends to increase the rainfall in this particular region historically. But I think it's more than that. Let me make a case for you here. You see, when we look at Baum's kind of one pager on this, which I do like, they say that in spring, coming out of winter into spring, that negative phase tends to favor this whole region as wetter than usual. Okay, so that's a good sign when we're thinking about the moisture that we need to prevent any sort of dryness. Here's the other part of it. We have been witnessing this for a while. That is the westerly turn in the winds. It's happening right along the equator. See it? Right there. I'll take this off. See the arrows? Right there. That is the negative phase of the Indian Ocean dipole. But we also have La Nina cranking over here, and it's trying to strengthen relatively rapidly. So can I put it all together for you? The flow's coming out like this and coming right back here, and it's coming across like that and across like this. The Southern Oscillation Index is very positive. The air is meeting in this region, and what that is doing is it's taking the position of the MJO, and it's going to try to park it for 2 weeks right there. That's all this is. So if you want to see it, when you look at a map, I don't know, let's just look at this map. This means the best rising motion, which is what we need to get tropical moisture to ascend, spread outward. It goes out from here. That's how it works, okay? But what you're seeing is that at the surface, it's coming in like this, rising in the middle, and that is one of the reasons why when you look at that week or that month-long forecast, we're so wet in this area. Now, we can tap into that tropical air from the north, and we're attempting to figure out if we're going there. So let's get into this. The ocean temperatures. See the cool water upwelling, the warm water getting pushed. See the cool water upwelling, the warm water getting pushed. That is all symptomatic of a negative Indian Ocean dipole and a negative ensophase, which we call La Nina. And this is what you get out of it. When the IOD drops, like it's forecast to do in October and November, we can go back and look historically at what that means. And I seem to have lost this web page. Let's see if I can get it to come back up here real quick. Oh, shoot. For some reason, it went down. Okay, there it is. It's got to wait. What you have here is going back to 1994. We have the IOD phase. So every time it's been up and every time it's been down. Well, I went into all of these years, because we've been looking so heavily at La Ninas lately, but I went into all these years that were negative in October, November, and I pulled them out and made a composite map of it. And what do you see? Sinking motion in the atmosphere and drier conditions here. Sinking motion in the atmosphere and drier conditions there. All of the best rising motion here. And for the most part, it was difficult for Australia to be dry in November and December when those two things were taking shape. Now, take note of a couple of other places, like South America. Dry southern Brazil. Dry into Argentina while wet in the north. Or you can go look at what the relationships are for La Nina. You see, La Ninas tend to help with the Indian Ocean dipole going negative. And that's why the best rising motion and rainfall, see I've got it labeled here for you, is wetter. While it's drier there, where we're trying to establish a crop right now too. It's drier across the U.S. cotton belt. The winter wheat belt's drier. It's drier in parts of Asia. I mean, take a look at this. These are the historical correlations. And I'm showing you all of these to round out this video by giving you that new forecast for November, December, January. And guess what you see in the forecast? Drier in the U.S. cotton belt, drier in southern Brazil and Argentina, drier here, drier in parts of Asia, wet. And so these two forces, the negative Indian Ocean dipole and the La Nina, are our two biggest drivers right now as we go through spring and start to peek our head in there towards summer. And the net effect is, if we just come back to it, I look out there at the forecast for the month of November, and even where I do see some drier areas, I don't know that it's aggressively dry, like major drought producing kind of dryness. And that's what I know. So you've now seen around the world, we talked about the big hurricane at the beginning, and we finished with some good reasoning behind maybe why the models look the way they do and how we can prepare for it. So that's it. That's where I'm going to stop today. You all have a good rest of your week. Be safe, and we'll talk again soon. Thank you.